All right, so let me start that part again. We know that the total moment has to add up to 0. And I can calculate 3 different moments about the axis AD. And when I add them up, they have to add up to 0. And in all cases, it is the unit vector of the axis we care about. And it's the dot product. And then it is the lever arm times the force. I'm sorry, lever arm cross the force. So in order to do that, right, we have the unit vectors for each one. This first one being BG. I'll write it down here. BG. The second one being BH. And then the last one is the force P. Right? So those are what we have. Now, I don't know the actual forces for BG and BH, but I know they both have the same force. I know I've said that more than once now. So I'm just going to list that force as F. The total force times 0.44 is the force in the I direction. The total force times 0.82 is the force in the J direction. The total force times 0.35 is the force in the K direction, right? So the unit vector times the force gives me how much force in each direction. So I can substitute all of those total forces, and I can substitute F for those. And in all cases, F is the same because they both have the same total force. So this is my whole equation, right? It is all of this plus all of this plus all of this, and that all has to add up to 0 because the moment is 0. So I've done all the work out. I'll kind of show it to you, but you'll start to see hopefully that that it works. All right, let me raise it a little higher so I can get all the parts in. So the first thing I have to do is the cross product, and I'm going to kind of talk through one of them, and then you can pause this if you need to. But first I do the cross product, and if I'm doing the cross product, it's this times this, this times this, this times this, 0.5 meters I times each component. But I know when I do I times I get 0, so I can just skip that one. 0.5 times F 0.82 works out to be this. Use my right-hand rule, that's in the K direction. 0.5 times negative 0.35 gives me this. Right-hand rule says it's in the J direction. And I've done my cross product right here, and then I'm going to dot it with this. Well, then with the dot product, I know that they have to be in the same direction to matter, so this 0.8I has nothing. This 0.8I has nothing to dot product with, so I can get rid of that. It's just 0.6K times 0.41K. All the other things disappear, so I have minus 0.246F. This is the moment that BG produces around the AD axis, right? It's not an actual value because there's still this variable F, right? But that's the moment about the axis produced by BG. Similarly, this is the moment about the axis produced by BH, negative 0.201 F. And again, F is the force that we don't know yet, right? The last one I can get everything for because I can cross product these two. I get negative 268K. And again, the only thing I care about in the dot product then is the 0.6K because the I doesn't dot with anything. So that one works out to be 160.8 Newton meters. That's the whole moment, right? So if I write that on there, it is a force times a distance, Newton meters. So that's the amount, that's the moment that force P produces about the axis AD. So when I put all those together, this is what I have. There we go. So it's a negative 0.246 F, because that's what I got, minus 0.201 F plus 160.8 equals 0. I rewrite this to make everything positive. I solve for F. F is 360 and 360 Newton. So that must be the force in BG and in BH. Okay, I hope this helped.